So I'm trying to explain about the new regulation in comparison with the old regulation. We start with the introduction. What is Electricity Act? The CEA measures relating to safety and electric supply regulations, the role of code of practices of BIS and the product standards by BIS. However, this will be a question, and Sri Apau will reply this after this introductory speech. He will also explain what is this Ieee rule and how the new systems are in place. So if we look at the accidents in our the accident statistics, approximately 55% happens on the low voltage, 11 kV or the distribution, about 43%, and above 33 kV, it is about 2%. So approximately it is like this. See here the values a little bit plus or minus 1 or 2, 3% plus or minus is not an issue. But what you should understand is majority of our accidents are happening in the 11 kV, 22 kV, 33 or the low voltage distribution. About 55% is happening within the consumer premise. So once when you start using electricity, that is the consumer premise, there you have 55% accidents and about 43 in the distribution, extra high voltage 2%. So our program, we are mainly focusing on these two areas, which is major threat. Out of these two areas, of course, in the distribution, expertise is available with the distribution companies, so we don't need to focus more because they are the experts. So whereas our main focus is towards the consumer premise. Now, the background of the measures relating to safety and electric supply regulations, it is based on the Electricity Act 2003, Section 53. The Parliament of India is giving assurance to all the citizens that the authority, means the Central Electricity Authority, will make measures relating to safety and electric supply regulations, which will be the rule or regulation which need to be followed for across the country. Also, the Section 177 says not only this regulation, there are several regulations made by the authority. Authority means the electrical, the Central Electricity Authority. The grid standard, measures relating to safety and electric supply and all. Our discussion is on measures relating to safety and electric supply. But in this case, you should understand one subject which is very serious. The Section 146 of the Electricity Act. Please note that Electricity Act covers so many subjects. Out of that, the responsibility of making safety regulations are given to CEA. So CEA has to make the regulation. Now 146 talks about punishment for non-compliance of orders and directions. Very important. Imprisonment for a term which may extend to 3 months. I will explain how this is applicable in one of my slides at the end of the presentation. Imprisonment, if you don't follow the rules and regulations, imprisonment is 3 months, a fine of 1 lakh rupees for each offense. If you continue the offense again and again, rupees 5,000 per day. This is the penalty which is included in the Electricity Act. That means, in case of negligence of the electricity distribution company, technically speaking, the officers of the electricity distribution company, not the lineman or the junior people, the management has to be these penalties actually has to be put on them. We will explain it later. Now, contents of the regulation. The 2010 regulation, it consists of chapter 1 to chapter 9 up to regulation 115. Also something more in the new regulation, On the right side, what you are seeing is the new regulation, chapter 1, chapter 2. Almost the chapters are following same way, but there are some additional requirements. The additional requirements were actually from the amendments which were made during or after 2010 until 2019. Amendment 1, Regulation 5, 5A, 32 and all. Amendment 2, Amendment 3. Now, all these amendments are included in the main regulation. As a result, what happens is the number of regulations had increased. If we look at the chapter 3, 4 and all, there is a confusion probably in the numbering between the old regulation and the new regulation. Anyway, not a big issue, but we will discuss it later. One of the main change which is going to come, or one of the main improvement which is going to come, is a kind of a clear definition of voltage. In definition 92, you can see this. Low voltage, anything up to 1 kV AC and 1500 volt DC, 1.5 kV DC. Of course, this need to be changed to 1000 volt AC and 1500 volt DC. Then medium voltage 1 kV and 33 kV, up to 33 kV, high voltage 33 and 150, extra high voltage above 150. So you must be surprised that earlier we were calling anything above 33 as extra high voltage, and how come this came into picture. There is a small background behind it. I hope it is due to that particular background. The definitions of voltage were not clear in our regulations and the standards. Yes, of course, the Ieee rule 1956 had some definitions which has been removed in the CEA regulation 2010. After that, there were no clear regulation on the voltage definitions. I'm just showing you some of the standards which we are referring this particular subject. The IS 17036, it is talking about, you can see these values. High voltage is 33 to 150 kV. Then 1 kV to 33 kV is medium voltage and so on. This is one of the latest IS code which is made for distribution system power quality. If we look at the IEV, International Electrotechnical Vocabulary, which is nothing but the online platform of ISO and IEC. Here the voltage has got only two definitions. LV means less than 1000 volt, HV means anything more than 1000 volt. The IEC 6, one moment, again I have a small power cut. Yeah, I hope the full screen you are able to see.
It is with 2 slides.
Okay, one moment, sir. One moment. Because on Saturday, sometimes it's a little bit risky. Hope this time it's showing only one screen.
Yeah, right.
Thank you, sir. Now the IEC 61036, this is talking some other definitions. Another IEC standard is talking about some other standards. Of course, in the IEC level, all these definitions have been changed to two levels, less than 1 kV and higher than 1 kV. If we look at the IS 12360, these are talking about the voltage band, but no definition for each band has been given. The Electricity Act says high voltage line, there are some definitions. Ieee rule has got some other definitions for low voltage, medium voltage, high voltage, extra high voltage. So this anyway is not applicable because the Ieee rule has been already removed or replaced with CEA regulation. CEA, the technical standards for construction regulation, mentioned as auxiliary voltage or control voltage, 1.1 kV power and medium voltage, or power and medium voltage above 1.1 kV up to 66 kV. So basically, if we look at our rules and regulations, there are so many definitions. Nowhere it is clear which people need to follow. As a result, what happens is a total confusion. For example, the electricity regulatory commissions of the state governments, for example, Delhi, DERC, they say according to them, low tension is, remember, tension and voltage is same. Low tension is single phase 230 volt, three phase 400 volt. High tension is three phase 11 kV. EHT is three phase 33 or 66 kV. If we look at Madhya Pradesh, they say almost probably similar to Delhi. If we look at Kerala, you will have a different kind of voltage. If you look at Tamil Nadu, you will have a different kind of voltage. Karnataka, again a different kind of voltage. Maharashtra, another kind of voltage. So each of the state regulator is using a different voltage. Actually, one country should follow only one rule or only one voltage band or voltage definition. So in the upcoming National Electrical Code, in clause number 3.12, we considered this, which is taken from the IS 17036 2018, because this standard has been made where the members from Central Electricity Authority and all the top leading organizations in India are present. So this standard is becoming common for them. So the same definitions are being taken in the NEC. ELV up to 1000 volt AC, 1500 volt DC. Medium voltage 1 kV up to 33 kV. High tension or high voltage 33 to 150 kV, and anything above 150 is EHP. The same definition has been taken in the CEA up in the draft. So except this small correction, 1 kV, it need a small change, 1000 volt AC. So probably the question which people are going to ask is, earlier we were calling above 33 kV as EHP, but what is going to happen to that EHP? Of course, then in future, slowly, probably, if this standard, if the regulation is final, then we have to change the name a little bit. In the regulation, what is very much important for us is the 650 volt, which has been followed for several decades. From the Ieee rule onwards, it has been changed to 1000 volt AC. So you cannot see any more 650 volt in the regulation. Of course, 650 volt is still appearing in a few of the places. Probably this is by mistake in regulation 37. In few places, 5-6 places it's coming, but I think it will be changed to 1000 volt. Probably a typographical error. There are two changes in the, if we start from the first 3-4 chapters. The 6, a new number has been given to Chartered Electrical Safety Engineer. Number 9, this is a new regulation, safety measures for operating and maintenance of load dispatch center. And in regulation 75, this is also anti-clamping device. This is also a little bit new. So few new standards or few new regulations also is coming up. Now, the regulation 33, I'm just showing you the regulation 33, but before that, one moment. Yeah, the regulation 33. I'm just trying to explain you some changes which is going to, which is included in the regulation. Regulation 33, testing of consumers installation. Here in the para 2, provided that recommended testing and verification as per IS 732, National Electrical or National Electric Code, wherever applicable, shall be carried out. Please make a note of this. This is an important change. So this means that for all the safety audits carried out in industries or the initial verification, you are supposed to follow the recommendations as per the National Electrical Code or the IS 732. In NEC, the upcoming NEC, LV as well as high voltage testings are going to come up. Here, the regulation, you see sub-regulation 2, supplier shall maintain a record of test result obtained in the schedule 3. Actually, here the schedule 3 is not enough for doing a safety audit because in IS 732 or the NEC, detailed formats are given. Probably if the regulation write instead of schedule 3, formats as per IS 732/NEC would be better. What is this regulations, or what is this? How does IS 732 came into picture? You must understand that worldwide for low voltage or safety in consumer premise, especially low voltage, the safety regulations are made by 60364. Actually, 60364 Part 1, Section 3 is a guidance for the national regulator of a WTO member country or a TBT agreed country to formulate their national regulation. So 60364 has been adopted as national regulation, for example, in America as NEC, NFPA 70. Britain, the same document is used as BS 7671. In Germany, the same document is used. In France or in almost all the European nations, the same 60364 or its adopted versions are used as national regulation for electrical safety. In India, the same regulation, the same 60364 has been adopted as IS 732 in recently 2019 and the upcoming NEC. So this standard talks about design, erection and testing. So to make it simple, please understand that globally the same regulations are used for safety in a consumer premise. We don't need to go to the American standard, British standard or German standard. Simply use Indian standard. You can find out the information about this NFPA 70 and the IEC in the NEMA or on the UL websites. Here I have put the link. If somebody want, I can give it later. Now, why I stress this is you don't need to go to the American standard or the British standard. This is very important. Now I will go a little bit out of the context and explain you how rule and regulation can influence the final safety in an electrical installation. What I am showing you in the screen is a tender specification from Chennai Metro Railways. This has come, I think, very recently, probably a few months back, March 2021. You can see here, look at this relevant code, the compliance codes. They are saying IS 3043, Code of Practice of Earthing, BS 7430, Code of Practice of Earthing. I don't know whether what they mean is IS 43 is a part of BS 760 or whatever it is. Then they say BS 7671, then they say IEEE, IEC, NBC. You see, the only standard which is replying is the NBC, National Building Code. Unfortunately, the subject of this tender is not included in NBC. So basically, the name given here is just for the sake of putting a name. Otherwise, it has got no meaning. So they basically, if you check, the tender is asking for compliance with all other standards other than the Indian standard. And they finally also have written IS 3043. And the funny part is, if we go through the tender, these pictures, you see there is a transformer. Neutral of the transformer is going to 2 earth pit. This transformer, another 2 earth pit. There is a DG 2 earth pit, body of the DG 2 earth pit. So what does this mean is, the tender, the whole tender specification still follows the 2 for neutral, 2 for body earthing, the same, that old concept, which actually doesn't exist in IS 3043 or the CEA regulation or any other Indian standard or not even in these IS, BS and IEEE standards. Nowhere this method of two separate neutral earthing, two separate body earthing. This is never written in any of these standards. Now, if we go and ask the tenderer, how can you make this mistake? They will say, no, this is written in IEEE 1000, ISO 1461. They will say something and simply escape from the responsibility. Technically speaking, from a good implementation point of view, they actually has to cancel all these standards and simply write IS 732. One standard reference is actually enough for this particular installation. We have made a blog. It is available in our website. Please go through the blog. In the blog, you can download these drawings, these specifications, and all these documents which I am referring to. But what is shown in this picture, DG earthing, two separate for neutral, two separate for body, this is absolutely wrong. Now, a small example. In the tender specification of the Chennai Metro, they have mentioned IEEE, several IEEE standards. Now, I'm just showing you from the IEEE website. IEEE website standards board, if you look at that part, they say IEEE standards are classified as standards, means documents with mandatory requirement. Recommended practice, that means documents which produce procedures and positions preferred by the IEEE are presented. That means this is IEEE's their preferred methods. Guide, documents in which alternate approaches to good practices are suggested, but no clear recommendations are made. Please read it again. Guide, documents in which alternate approaches to good practices. That means it is not the good practice, it is an alternate approach to the good practice are suggested, but no clear-cut recommendations are made. So I hope it's very clearly written in the website. Then trial use means the old document. So guide, please make a note of it very carefully. Now, what kind of documents are there in IEEE? You can see some of the IEEE standards are the nationally accepted. In America, it is accepted as the national regulation. It is the one is National Electrical Safety Code, which is the regulation for transmission and distribution of electricity. It's an IEEE document. That is a standard, of course. I think this is how they do it. But the second and the third part, I am very clear. IEEE 142 and IEEE 1100. These are IEEE recommended practice. So it's not a standard. It's a recommended practice. Now come to the third one. IEEE guide for safety in substation. It's a guide. Guide is an alternate method to achieve safety. This is IEEE 80 is a guide. Now, also you please understand that IEEE is a guide which never mention the applicable voltage. Up to what voltage this guide is applicable is never mentioned in this guide. And it says AC substation grounding. In America, AC substation, the definition is very well known, so they know how to use it. Whereas this standard is misused in India and put for tenders like our Metro Railways, which is of national interest, and the whole thing is spoiled. Let me show you how it is spoiled. In America, substation 66 kV, they have HVDS, high voltage distribution system. Every consumer premise will have a small transformer, 20 kV primary and 120 or 240 volt at the consumer premise. In America, IEEE uses IEEE 80 is used for making the grid to reduce touch and step potential at this place. Whereas in India, we use the same touch and step voltage reduction measures at this place, 11 kV input and a 230 volt. We take the fault current of the 230 volt system and try to make it. How this is shown, you see here, the annexure of this particular tender, main earth mat calculation. You can see here, system voltage 0.415, 400 volt. System LT fault current, 5 50,000 ampere, 50 kiloampere. 50 kiloamperes of fault current is going to flow at 415 volt. So they don't even understood the, or they don't even imagined about a TT system. In a TT system, if you have two earth electrodes or one of 1 ohm each, then your fault current is not even more than 125 amps. So here the system is selected for 50,000 amps. You see here the heading. This is a software simulated report based on IEEE 80 for 415 volt application. Now you see all these calculations, so many calculations. Our engineers are always impressed with this calculation because they feel that calculation from computer will save our electricity or save our installation. This is the feeling. But now you see here GPR for fault at LT system. That means fault at the low voltage system is creating a 415 volt. That means basically line to neutral, line to earth fault, probably 230 volt fault is creating a ground potential rise of 15,000, 15 kV, 15.672 kV. So this much voltage at 230 volt fault is creating. It looks really funny. Now, how we can apply this? The fault voltage is 230 volt. GPR is 15,000 volt. All of you knows that there is an earth electrode and each earth electrode has got an influencing area. Whenever there is a fault current flow through the earth electrode, GPR or voltage gradient is created, and according to this IEEE calculation, GPR in this particular case is 230 volt is creating 15 kV ground potential rise. That means from the earth electrode to the surface of this influencing area, you will get a potential difference of 15 kV. And means 15 kV is created due to a 230 volt fault. This is fantastic. Very good idea. This idea can be used for updating, stepping up the voltage. More than earthing, it has got so many other applications. If you wanted to increase the voltage, you put an earth electrode and send the current through the earth, your voltage will be increased. So this kind of ideas are propagated in the market. This is called as propaganda business. Who propaganda? This is a lot of software companies, those who are having IEEE software. So in the tender, it is written, you should submit, the vendor should submit the calculation as per IEEE in a particular software. And that particular software is sometimes 30 to 40 lakh rupees worth. That means the only few vendors are eligible to participate in this tender where this is not at all absolutely required. That is the point. For this tender, which is for a 230 volt application, not at the IEEE 80 is not at all applicable, but because of unawareness, such points are included, and this is we call as propaganda business. Please don't run behind this propaganda business. Try to follow our national standard. For example, another propaganda business. As I told, 60364 in America, NFPA 70. NFPA 7 without compliance to NFPA 70, you cannot run your building. NFPA 70 compliance is 100% mandatory. In addition, there are standards like NFPA B, C, D, E, F, and all these things. So I think in NFPA 70, E or D, somewhere arc flash study and thermography are recommended. But please understand that the building has got NFPA 70 mandatory. Over and above, you do arc flash study and thermography to make your building more safe. Whereas when it comes to India, NFPA in several industrial buildings, of course, the arc flash studies are made as per NFPA 70. It's a propaganda business, but the basic, the fundamental testing as per NFPA 70 is not carried out. This means the fundamental testing recommended in IS 732 1989, 10 testings are included in 1989. These are unknown in the market. So we are not doing the fundamentals properly, and we jump behind the propaganda business and run behind these the modern the bigger testings. Wherever we attend nowadays the electrical safety trainings by industry, they always recommend to go for arc flash study, and they always go for thermography. But once when we ask, have you tested fault loop impedance and found out the tripping time of your MCB? The very basic, the simplest test, then they say, oh, what is fault loop impedance? We don't do all these small things. We do only the biggest thing. So please understand that what is written in IS 732 is the fundamental basic requirement. So I put it, the basics as per NFPA 70 is unknown, but we always call. So this is called as propaganda business. So our regulations and rules must be free from such propaganda business. Anyway, let me go to the regulation number 38, provisions. In Regulation 38 for buildings more than 15 meters. Earlier it was Regulation number 36. Due to 2 additions, the number has been increased. So there are 2 additions: fire retardant low smoke cables and using bus bar trunking for high-rise buildings are recommended. But I think the sub-regulation numbering, there is a small mistake. Both are 6, probably to change, or I don't know, maybe this is A and B. Then lightning protection shall be as per 62305. Electrical verification, please note at the sub-regulation number 10, electrical safety verification of the installation at the time of construction shall be as per IS, sorry, it is missing something, little bit is missing. It is as per IS 732. It's there on the previous, you can see it here. The sub-regulation 8, electrical safety verification of the installation shall be done as per IS 732. So my request to every house, every high-rise building is, if this once when this regulation comes into picture, before doing thermography or this arc flash and all these things, first you do the test of IS 732. Over and above, you can do whatever you want. Then here the hospital safety is also included somewhere. You see here. I think I skipped that particular part. Hospitals also should do testing as per the IS 732 is mentioned somewhere. Then regulation number 42, which is chapter 5. The earlier regulation was regulation 40, a test of insulation. It was asking for insulation resistance test, but now in the new regulation, it is changed to has applied the tests as per IS 732 part 6. That means all the tests are becoming mandatory, not only the insulation resistance test, but all the tests. This is a major change. Regulation number 41, the earlier 41, currently 43. This is the biggest confusing subject, earthing. On the first part, you can see the voltage 1000 volt and 1500 volt DC. The earlier 650 has been removed now. The major change in this regulation is sub-regulation 1. Earlier, the regulation was asking to connect a neutral conductor to 2 separate and distinct earth electrodes in soil. This was actually creating the biggest confusion in the market. Actually, this regulation was talking about neutral conductor in a public distribution system, not about the neutral terminal of a transformer or a DG, but a neutral conductor in a public distribution system. But however, in the new regulation, without any confusion, it is modified. It shall be earthed as per IS 3043. Very clear. So IS 3043 section 4 already have this particular clause. You should do as per IS 3043. Similarly, the other major changes are So many sub-regulations are removed in this particular case. In a DC case, you should do as per IS 732. Every building, please look at the regulation number 5. Every building shall have protective equipotential bonding by interconnecting exposed and extraneous conductive parts as per IS 732 and IS 3043. I would say this is one of the most important change in the regulation. Globally, electrical safety in a consumer premise, protection against shock is achieved by protective equipotential bonding, number 1. Number 2, automatic disconnection of supply. So the safety measure is called as fault protection by protective equipotential bonding and automatic disconnection of supply. Whereas protective equipotential bonding was rarely carried out in Indian buildings. Now the regulation had very clearly written it. As a result, the electrical inspectorate or the electrical inspectors, they will verify this, the integrity of these, the reliability of this particular bonding. However, if you do all the tests, it is automatically included. Now, the frame of every generator and the motor, it shall be done as per IS 3043 and IS 732. All of you know that in the figure 38, 39, 40, 41 of IS 3043, the generator earthing, including neutral, is given. You can refer those pictures. Now, all earthing systems shall have the first one is equipotential bonding conductor, the conductor to carry 100% fault current. Number B, you please read it very carefully. Earth fault loop impedance shall be maintained sufficiently low to permit adequate fault current for the operation of protective device within the time stipulated in IS 3043. Very important. The simplest method, the initially I mentioned, in industry, if we ask, have you checked the fault loop impedance and ensured that your MCB is tripping within the time, then people ask us back. We never do it because mostly it is unknown. Now in the regulation, this has been included. You have to be careful. Then the supplier, all earthing system belonging to the supplier shall do the testing of these earth electrodes. Now you please read these 3 clauses, very important. 11. Earth fault loop impedance shall be tested to ensure automatic disconnection of protective device, and a record of every test made and the result thereof shall be kept by the supplier for a period not less than 2 years after the day of testing and shall be available to the electrical inspector when required. So this sub-regulation is talking the responsibility of the supplier. Energy supplier should do this test and keep the record. How they have to do it? They have to have a fault loop impedance meter. They have to go to the consumer premise. They have to test it and put it on the record. This is the correct method. Similarly, the second one, earth fault loop impedance of each circuit shall be limited to a value determined by the type and current rating of the protective device. What does this mean is the consumer, the user of electricity, either the chartered electrical engineer or whatever, the consumer should ensure that these testings are carried out as a part of self-certification. So the supplier's responsibility is there, consumer's responsibility is there. Now then item number 3, where multiple sources are used in the same installation like transformer and DG with changeover facility, fault loop impedance shall be tested for both the sources and automatic disconnection of supply shall be ensured. So not only for, because once when your source, type of source changes, the impedance of the circuit changes. Probably an MCB will trip at during working with a transformer supply, but it may not trip during a DG supply. So what it is required is you should test for both. The next regulation, regulation number 42, I will go a little bit quickly because in between we had some small disconnections. The supply of electricity, earlier it was talking about in a typical fashion, but let me go to the new one. The use of electricity. Please understand the difference. Supply of electricity means it is the responsibility of the supplier. Now, the use of electricity. That means whenever you start using electricity, that means at the point of commencement of supply, to every electrical installation shall be controlled by an RCD whose rated residual operating current shall not exceed 30 milliamps so as to disconnect the supply instantly on occurrence. So basically, at the point of commencement of supply, every installation shall have a 30 milliampere RCD. Earlier it was some confusion. Up to certain kilowatt of the load you need it, below that you don't need it. All these things are removed. Very simple. Every installation you should have an RCD. Also, please read the second para of this regulation. Provided further that such protective devices shall not be required for overhead supply line having protective device which are effectively bonded to the neutral of the supply transformer and conforming to regulation 76. Actually, here overhead supply I just striked out because nowadays more than overhead supply, underground supplies are also there. So probably removing this is improving the standard. Now what this says is, second para says, in case of a TN system, if the supply is TN system, RCD is not required. So this is very important because you cannot run a small scale industry or an industry with 50-60 kilowatts of load having lot of electronics with a 30 milliampere RCD at the point of commencement of supply, because RCD will create nuisance tripping. Whereas if you look at the second part, in case of a TN system, you don't need to use RCD. What is TN system? TN system is recommended in the regulation for the electricity supply company. So basically, we have the option. Instead of 76, I think this is a spelling mistake, probably 74 is correct. And instead of protection device, supply lines having a protection device which are effectively bonded. Protective device is not bonded to neutral of the supply. Protective conductor is bonded to the neutral of supply. Small changes probably are essential. The regulation number 74, earthing. You know very well, this part of the regulation talks about continuously earthed by providing a continuous earth wire. What does it mean is at the distribution, any voltage, any distribution below 33 kV, the energy supplier is supposed to provide a continuous earth wire. That means it is like a 5-wire system, 3-phase neutral, and the 5th wire is a PE conductor. So that means in a 3-phase supply, I am just showing some of the regulations, the old regulations, which this subject is explained. Regulation number 14, 15, 16. Regulation number 15 is explaining about the cutout and link. Regulation number 16 is talking about the earthing electrode, and all these the TNCS system, TNS system are explained in this regulation. It means there is a metallic fault return path in the distribution. In case of any fault at the distribution or at consumer premise, sufficient fault current returns to the source through the metallic fault return path. As a result, easy identification of the fault is possible and disconnection is quite easy. That was the idea behind these regulations, and that is what is written in the standard. But what do? In most of the consumer premise, this is missing. The link TNCS to TNS link is missing. As a result, the actual network becomes TT. So if it is a TT system, of course, 30 milliampere RCD is 100% necessary. As per the new regulation, also IS 3043, IS 732. Then continuous earth wire for easy fault return of source is also recommended. Also, this part of that regulation also talks about the guarding, how guarding is required, how earthing of each pole has to be carried out, how the continuous wire need to be done and all. But to tell you the truth in our distribution, nowadays, even in road crossings, important road crossings, guarding is missing. During our childhood, every road crossing, there was a guarding, but nowadays it is missing. On the roadside where crowded places, as well there is no guarding. As a result, in case of any isolation or in case of any mechanical break in the phase live conductor, it falls down and it creates accident. So generally, the supply companies are careless in implementing these regulations. Most of the all over India, the supply companies are actually not taking care of the protection of or the safety of people. They do it. They only wanted to pull 3 wires and give the supply to the consumer and get the money. Otherwise, the safety is not important for them. They are only interested in protecting their equipment, not the safety of people. So in a place, if there is a guard wire missing, and if the phase conductor falls down, and if somebody gets electrocuted, if we apply the section 146 of the CEA, the Electricity Act, actually, with a good lawyer, what will happen is the managing director or directors of the energy supply company, they have to be imprisoned up to 3 months, fine 1 lakh per accident, and rupees 5,000 per day in continuing the failure of compliance. Actually, if we read our Electricity Act and the safety regulations, in case of accident of a person or an animal or whatever, the responsible people, they are not the small level people like the lineman, they are the top management, because these are policy decisions. Making 100% guard wire according to the regulation, it need money. The smallest officer may not be able to do it. This is a policy decision. So directly the top management of the distribution companies are responsible. And if anybody want legal support on this particular case, please get in touch with us. We will give you technical support in this case, and finally we can see that the top management is put in they are really put in trouble as per the provisions of the regulations and the rules. Now, one more. I have only one or two more slides. So let me go quickly. Lightning protection, there is a duplication, regulation 46 and 77. Earlier it was 74. So 2 places lightning protection is coming up. In the new added version in 46, the surge arresters shall be connected with 2 independent earthing connections. This is actually a mistake. And above 1000 volt shall be protected against 62305. This is not applicable, because 62305 is applicable only for buildings and structures, not for high voltage transmission line or distribution line. So there is already an existing regulation. And in this existing regulation, the first paragraph is perfect, but the second paragraph, there is an issue. All of you know that in distribution, the earth lead wire of the distribution is taken parallelly, and longer wires are used and so on. But you refer to the IS standard 15086, a lot of new methods are being implemented, so you are supposed to make those provisions. In fact, I have one slide which I have hidden. Let me show it to you. What is written in the IS standard? In the IS standard, lightning arrestor, there are 3 recommended connections. The first one is like the system which we follow right now from the high voltage line. This is the zinc oxide varistor. This is the transformer. The earth wire goes parallel. You see L3 is longer wire, L5 is longer wire. As a result, what happens is during a surge current flow, due to the surge impedance, there is a huge potential difference created. As a result, the effective protection level is not achieved. Your transformer will be in trouble. Whereas the second method, the surge arrestor body, the earthing is connected to the body of the transformer. This is an improved method. And the third one is the very good method. These are explained in the IS 15086 part 5. Please go through the standard and understand it to do it. So preferably, I would suggest that the second para of this regulation 77, second para has to be modified as surge arrestor shall be selected and erected as per IS 15086 part 5. So with this, I make a stop for my presentation.